Hi everyone. So if you were a regular traditional student of mine, what I would do when I reached this unit, when I talk about radicals, is I would put these guys up on the board and I'd give students a chance to evaluate them, and I'd give about 5 minutes or so and see how they do. So I'll do the same thing with you guys. Go ahead and pause this video for a second and see how you do. If you can get as many of them right as you can, maybe time yourself and see how fast you are. Give yourself about 5 minutes. That's usually what I do with my traditional students, is I give them 5 minutes. So go ahead and pause and see how you do. All right. If you didn't hit pause, then you just experienced an awkward silence there. Okay, let's see how you did, all right? Square root of 25. Hopefully that's pretty easy for you. It's just 5. Now, granted, a negative 5 times a negative 5 is also 25. But we're going to look at what are called the principal square roots, or the positive roots, okay? The negative roots, let me talk about that in a couple minutes here. Well, I'll talk about it right now. Let's skip over here. The negative square root of 25. That's going to be the negative 5, okay? So that guy right there would be the negative root, and this guy right here is the positive root. While I'm talking about it, let me bounce over here to the square root of a negative 25. Now that one is going to be not real, okay? That's not going to be negative 5. Because what you're after here are two numbers that will multiply to each other to become the radicand. By the way, the inside of the radical is what's called the radicand, okay? So a negative 5 times a negative 5 is going to be 25. But the negative root we're accounting for by putting the negative outside the radical there, okay? If you have a negative inside the radical, what you're saying is, are there any two real numbers that you can multiply together to get to be a negative 25? There are not two real numbers to become a negative 25. There are two not real numbers, but I'm going to cross that bridge another time. And of course, the square root of 25 is 5. Let's keep going. Square root of 0 is 0. That one's not too bad, I hope. The square root of 9 over 25. That one's going to be easier than you might think. Just take the square root of 9. That's 3. The square root of 25. That's 5. So 3/5. The square root of 0.36. Granted, if you have a calculator, that'll work for you just fine. If you don't have a calculator, what you can do is take 0.6 times 0.6 and multiply that out, and then move the decimal accordingly, but you're going to find out that it's going to be the 0.36 there. Let's look at variables here. So what we're looking at here are two variables where two of the same amount to become this square root of x to the 10th here. So in other words, we're looking at something like this. Now remember that rule for the product rule for exponents? If you have like bases get multiplied, you add the exponents. 5 plus 5 is going to be 10 here. So what I'm looking at is I have a group of 2x to the 5th there that can come out and just become the 1x to the 5th. Now, if you were taking an elementary algebra class, I probably would have taken that approach. But as an intermediate level, I like to show the little shortcut here, which is this. Your index here, the index is the little number inside the little crook of the radical here. The index in this case would be like a little 2 here, right? So what I tell people is say, okay, let's take the exponent inside the radicand here and divide that by the index. 10 divided by 2 is 5. Okay, that works a lot faster, works a lot better for people. If it doesn't divide it evenly, well, that's a bridge I'll cross at a later date. But if it goes in evenly like that, it comes out pretty slick here. So let's look at the square root of 36x to the 6. Well, the square root of 36, hopefully you already got that part, it's 6. As for the x to the 6 part, remember our index here is a 2, so 6 divided by 2 is 3, so 6x to the 3rd. These two have been done. The cube root of 0 is going to be the same thing as the square root of 0, it's still 0. Okay, so again, what we're looking at with the cubed root is a number multiplied to itself 3 times to become this radicand. 0 times 0 times 0 is 0. So let's use that idea here for the cubed root of a negative 8. Now sometimes people say that that's not real, in which case it would be incorrect, but I see where they went wrong there. They're saying, well, wait a minute, the square root wasn't real, so why can't the cube root also not be real? Well, because in this case, we're looking at a number that you can multiply to itself 3 times to get to be a negative 8. And a negative 2 will do that. Right? Negative 2 times a negative 2 is a positive 4 times a negative 2 is a negative 8. Right? 4 times negative 2. So a negative 2 times a negative 2 times a negative 2 is a negative 8. That's a number multiplied to itself 3 times, so that'll work. Similar story with the cube root of 1 over 64. Cube root of 1 is 1. Cube root of 64 is not 8. It's 4. So 1/4. Looking at the cube root of x to the 9th, hopefully this idea will give you, hopefully you've speedily got to your conclusion there. It's going to be x to the 3rd, right? 9 divided by 3 is 3. The cube root of negative 64 x to the 6th. Well, the cube root of a negative 64, the cube root of 64 is just 4. The cube root of a negative 64 is possible. It'll be a negative 4. And hopefully you figured out the 6 to the 6th business. 6 divided by 3 is 3. Or, excuse me, 2. So negative 4x squared. And the 4th root of 16. Okay, we're talking about numbers multiplied to themselves to get to be 16. And asked to do this 4 times, so I think 2 will do it. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So 4 2's will do that, right? So the 4th root of 16 is 2. Let's try the 5th root. It's an odd root. Now, you can take odd roots of a negative number and come out with it being real. It's when you're taking an even root of a negative number, that's when it's going to be not real. All right, so if I try to take the 4th root of a negative 16, in fact, let's try that. The 4th root of a negative 16, that one's not real. Because I've got an even root there, okay? But the 5th root of a negative 32 is going to be a negative 2. Right? Negative 2 times negative 2 is a positive 4. Times the negative 2 is a negative 8. Times the negative 2 is a positive 16. Times the negative 2 is a negative 32. How about the negative of the square root of 36? Kind of coming back to what we were doing earlier. If you got negative 6, then you're correct. The negative here sticks around. So really you're just doing the square root of 36 and then you've got it. Alright guys, there was a whole slug of them. How did you do? In part 2 I'm going to do a few more along with a property we're going to need, but this video is plenty long as it is.